Hey guys, sorry that I'm splitting this video up in two. I just feel like the information in all of these readings is very heavy. It's just almost too much to put into one video. So again, I am splitting this video. So when it comes time to doing the lab, it may be a little bit harder to do since you don't know all the properties of covalent bonding, but that's okay. And I do want to apologize because I also have lost my voice. So it's actually really hard to do this video. So I know I sound ridiculous. Okay, at the end of this video, you should be able to describe how the electronegativity difference between two atoms in a in a covalent bond results in the formation of a nonpolar covalent, polar covalent, or ionic bond. Describe how molecular geometry plays a role in determining whether a molecule is polar or nonpolar. And those are the two things that we'll do in this video alone. The other two facts we'll do in part 2 of this video. All right, so I want to begin by doing some recall on some information that we talked about quite a bit ago, and it's all about electronegativity. And so remember, when we talked about ionic bonds are the transfer of valence electrons, and those valence electrons are transferred due to the fact that atoms have electronegativity, meaning they have an attraction to valence electrons. Some atoms have a higher electronegativity than others. So in ionic bonding, those will essentially, some of those atoms will actually just take those valence electrons rather than doing like a gentle sharing, I guess. Because if you remember, sharing valence electrons is only involved in covalent bonding. So what is meant by the electronegativity of an element? And this is another recall I want to talk to you about. So electronegativity, again, is defined as the relative ability of an atom to attract electrons when present in a compound. And I'll show you a table in class of what these electronegativities look like. But remember, from our trends, generally the halogens and the nonmetals are going to have higher electronegativity than the metalloids and the metals. And that's a really important fact because then that shows the actual taking of valence electrons in ionic bonding in comparison to the actual sharing of covalent bonding. So there is different degrees of ionic or covalent bonding. And what I mean by that is the fact that you can calculate the electronegativity between two atoms. And again, I am going to show you the table of all of the figures or all of the atoms with their electronegativities so you understand what I'm talking about. I'm not actually going to do it in the video because I'm trying to avoid these videos being super long like the previous ones. So I'll show you examples in class. You may want to leave notes in between this slide and the next so that you can add the notes for electronegativity and what the examples would look like. But a big thing to bear in mind, again, is that nonmetals typically have higher electronegativity than your metals. And that, again, is going to determine that attraction between your ionic and covalent bonds. So I already stated the degree to which a given bond is ionic or covalent is determined by calculating the difference in electronegativity. So high electronegativity between two atoms generally indicates an ionic bond in comparison to low electronegativity between the two atoms generally indicates a covalent bond. Because remember, in covalent bonds, we're generally sharing those valence electrons. You guys, I'm recording this video and Jace just literally looked at me and said, please stop talking. Anyways, all right. So now that we know the distinction in electronegativity between the two types of bonds, we're going to focus on just the covalent bond part because that's what basically all this chapter is about. So there are two different types of covalent bonds, and it's all indicated by the difference in electronegativity. So a bond in which the electronegativity difference is less than 1.7 is considered to be mostly covalent in character. So we already know that. Covalent bond, sharing of electrons. However, again, we distinguish between nonpolar covalent and polar covalent. A nonpolar covalent bond is a covalent bond in which the bonding electrons are shared equally between the two atoms. Good examples of this would be like your diatomic atoms found naturally, which would be like Cl2, H2, F2, those types of atoms those types of bonds are going to share equally because they both have the same electronegativity. So the difference between them in electronegativity is 0. So the electrical charge is balanced between the two atoms, which makes sense because they're the same atom. So a pull on either side of them to get away from each other will just be an equal pull. In comparison to that, we have what's known as polar covalent. And this is when a bond in which the electronegativity difference between the atoms is between 0.4 and 1.7. And this is called a polar covalent bond. So a polar covalent bond is a covalent bond in which the atoms have an unequal attraction for electrons, so the sharing is unequal. Not that they're not sharing, but one side is pulling a little harder than the other. So think of tug of war. You both are sharing the rope, but if one person is stronger than the other, then they're going to have more of a pull on the rope than you would, or whoever the other side is. So in a polar covalent bond, they can be called just regular polar bonds. So if you want to just call them polar bonds, that's just fine. And the distribution of shared electrons within the molecule is no longer equal. So there's a pull on one side more than the other. And how you represent this is by an arrow. So I'm going to do one example for you quickly. So if I had H bonded to F, that would be the Lewis dot structure. How you represent where most of the electronegativity is you can either do positive and negatives, but I'm not going to do that here. I'll do that in class. I think that's a little more confusing than just drawing an arrow to indicate, I can't draw the point on my arrow, to indicate the direction of greater electron density or greater pull, if you will. And we'll do a lot of examples of these in class, so don't worry if that doesn't make sense yet. And the very last concept I want to talk about is what's known as molecular polarity. So we've learned about these molecules that have been formed. And when a molecule has one end of a molecule that is slightly positive and the other end is slightly positive, this is what's known as a polar molecule. So polar covalent bonds create polar molecules, which makes sense, I hope, because you have the greater pull on one side than the other. So I already showed you the example of HF, and that is a polar molecule because of the fact that you have one positive end and one negative end. The negative end is always going to be towards the more electron-dense atom. So in HF, fluorine was more electronegative, so that it's going to be the negative end in comparison to hydrogen, which is the more positive end. Polar molecules contain, like I said, two sides on opposite ends of each other. These are also known as poles, so you can think of the north and the south pole. A molecule with two poles is called a dipole. And in class, I'm going to show you some examples of how molecular shape influences this. I do not want to do this on this video because I want to show you more about dipoles, and I feel like if I explain this or if I try to show you on the video, it may be more confusing than not. And my throat really hurts. So if you have any questions, please ask me on Edpuzzle.